All right, exercise 15.3b. This is a good one. It combines two concepts into one. We are given the reaction 2H2S in the gas is in equilibrium with 2H2 gas plus S2 gas. And this reaction occurs at 1065 degrees Celsius. So adding 273 to that number, we get 1338 Kelvin. Okay, that'll serve us later. We are told that the Kp for this reaction is 1.2 times 10 to the minus 2. We are asked to find Kc, not for this reaction, but for the following reaction. It looks very close to it. Hydrogen plus 1/2 S2 is in equilibrium with H2S. So if you're following along, hopefully in the textbook you've seen that written. Well, this question combines an idea that we did in an earlier question, except they've given us Kp and not Kc. So what I suggest is to calculate a Kc value, and then we can do the necessary operation on that Kc value to convert it to a Kc for the new reaction. So first of all, convert this Kp into a Kc value. So in the last question we saw that Kp was equal to Kc times RT raised to the delta n. Therefore, Kc is equal to a Kp value, which is given, divided by RT raised to the delta n for the gases. And that's the same thing as saying your Kp value times RT raised to the negative value of delta n for the gases. Okay, so Kc for that above reaction is equal to 1.2 times 10 to the minus 2, and that's multiplied by my product, RT. So we talked about this in the last example, which value of R that we do use. And that's multiplied by 1338 Kelvin. And I'm not using units here because Ks don't have any, and I'm assured that if the temperature is in Kelvin and the R value is this value, that we're on the right track. The tricky thing about that temperature in this question is that 1065 at first glance, it's such a large number, you might think it's already in Kelvin, but that was in degrees Celsius. Right, so what is the change in the number of moles of gas? That would be 2 plus 1 minus 2. 2 plus 1 minus 2, and the negative sign is there in front. And when we figure this out using the calculator, we get an answer of 1.07 times 10 to the minus 4. Okay, now the question is asking us to determine the Kc value for a related reaction, and that's H2 gas plus 1/2 S2 gas in equilibrium with 1 mole of H2S. And it's at the same temperature, 1065 Celsius, or, since we've converted it already, 1338 Kelvin. The question asks us for the Kc value for this reaction. And so, just like in an earlier example, we found out what we did to this reaction to arrive at this reaction, we would multiply it by a factor. And so therefore the new k is the previous k raised to the power of that factor. So the question is, what did I do to that reaction to arrive at this one? We divided it by 2 and reversed it, right? So we reversed it and then we divided through by 2. So in other words, this reaction, this top reaction, was multiplied by a factor of minus 1/2. That effectively reversed it and divided it by 2. And therefore this Kc value is equal to the one that we just found, the original Kc, and that's 1.07 times 10 to the minus 4, and that is raised to this number, minus 1/2. That's the same thing as 1 over the square root of 1.07 times 10 to the minus 4. And punch that out on your calculator and you get a final answer of, correct answer of 96. Great question.